That's a really interesting question.
Yeah, this is a good question.
I mean, that's a really interesting question.
Good question.
Oh, that's a good question.
You're asking a really excellent question.
It's a great question.
I love this question. Okay, go on.
Yeah, that's a really interesting topic.
That's a great question.
It's a good question.
Ooh. Now that one is a really, really hard one.
That's a great question too, Nadia.
Welcome back to The Doctor Is In. This week's episode highlights one of Nadia's special talents, asking great questions. It's a strength that has helped her solve many a problem for our clients and get some great insights from our guests. What are they going to be talking about? Well, that's a great question.
We talked about red and blue, and now there's green, and now we see full spectrum, right, lamps. There's a lot of research, fundamental plant science research that we see being done with looking at tunable LEDs, hitting these specific spectrums and ratios of spectrums of light for different species of plants. Something I always wonder is, if we find a magic ratio, and that magic ratio is different for 5 different species of leafy greens, and I'm going to grow those 5 species of leafy greens in my vertical farm operation. Is it practical and realistic to design my vertical farm facility to have 5 different ratios of spectrums of light for those 5 species? Or in the end, am I just going to pick one spectrum or one type of light that can sort of serve all their needs, right? In an okay way, right? So I'm not doing anything specific for any species, but I'm kind of finding a more broad range spectrum that fits them all. I just want to ask you about the practicality, I guess, of some of this research that we're doing on light spectrum, and if in the end, growers are just going to pick a full spectrum light anyway.
Right. Yeah. So you're asking a really excellent question, and it's, do we appeal to the practical or to what you might love? Mm-hmm. So I love spectrum. I really love spectrum. I also love driving a standard transmission car, but in the last few years, I drive an automatic transmission. Can you get better gas mileage with a standard transmission? Yes, you can. It makes it easier to rent a car in Europe.
Yeah.
but is it really worth it? And again, it's like car company. I mean, to me, that's kind of a good comparison, because yes, you can eke out a little bit better flavor, maybe a little bit better nutrition by getting the spectrum exactly right. The question really for growers is, what will your customers pay for? And people that are outside the realm of being super tasters, can they even taste that difference that maybe some people can? And I think that's been, one of the real questions. So a lot of the spectrums that several of the lighting companies are providing, they're just really good basic spectrums for a broad range of plants. And could we get more out of having adjustable spectrum? Absolutely. But I think that it's really dependent on having a high value crop. And this is where it gets interesting, where, strawberries are being grown by some of the farms now. Is there a crop that is of a high enough value that requires that special taste, that, the aroma, the sweetness, the bricks of a strawberry, that somebody might pay for, that warrants that spectrum that's really dialed in? So I think that, we'll see a lot to come in the research associated with spectrum, but I think we're also in a good place right now with the lights that people are providing for a lot of different plants.
Okay. The other question that I wanted to ask you related to that is, you said that commercially you're getting funding to study these different wavelengths of lights for, I'm assuming, for different plants. A question that I always have when looking at the plant science or the scientific research around looking at 630 nanometers versus 650 nanometers versus tuning the spectrum for different stages of a lettuce crop or a cannabis crop,
Is it practical to apply these various spectrums in a commercial application? Or are growers just going to choose the most efficient or cost-effective broad spectrum white LED that kind of just covers it all?
Yeah, this is a good question. And the short answer is the importance of quantity of photons is always underappreciated. You've just got to have the photons drive photosynthesis. The effective quality of light, the ratios of colors, is overemphasized. Yes, we can manipulate plants with light color, but you've got to have the total quantity of light there. And even though I've spent got lots of papers and a huge part of my career looking at ratios of colors, it's the quantity that is really critical. And a real specific example is because people don't always have access to high intensity LED fixtures, an enormous amount of the literature is done at low light levels, low photon fluxes, like 1 in 200 micromoles per meter squared per second. And I review papers constantly with these low light levels, and they show effects of ratios of colors. But I can tell you that if you get up to higher light levels, many of those effects disappear. If it's sort of like if you're starving, it matters what you eat. But if you have an adequate diet, you don't have to be so strict about what you eat. That's quality of food and quantity of food. So we have a lot of artifacts in the literature a lot of studies in the literature that only apply to plants grown under very low light levels. And commercially, you just wouldn't use those low light levels. But that's taken us a while to discover that things we learn at low light don't apply at higher light levels.
A question kind of comes up because you worked out in the field and all these variables you just mentioned, and then you go indoors and you can you can protect your crop from a lot of those natural challenges that you might deal with outside. Do plants and cannabis or plants in general, do they need to have a super consistent environment that you can give them indoors? Or have you learned from being outdoors, plants are pretty resilient, they kind of roll with the punches, they'll recover, they maybe actually might express some quality characteristics by being, exposed to these variabilities that we just can't or are afraid to recreate indoors?
Yeah, that's a really interesting topic, and it's something I think about a lot. My general theory, like my general school of thought, is still keep the plants less stressed in indoor agriculture and probably in outdoor agriculture as well, because there's going to be more than enough stress points that they're going to encounter in their life cycle that we don't really need to add to them. I am probably at the opposite end of the spectrum compared to a lot of other growers that really think you need to do a lot of high stress training like super cropping or different types of things to potentially increase yields or cannabinoids. And I'm sure there is some science behind different high stress techniques that have an impact. One thing that I have done that is a little higher stress, and this is really just based on, I think it was Darren Kaplan's research, was drought stress. And I do find drought stress kind of interesting. And I had been using some like kind of calculated drought stress in the field for different culinary herbs. So like drought stressing thyme or basil. And there's studies on all of those. So you can always look back to different crops and find drought stress studies. There's hundreds in like aromatic herbs and stuff like that. So I like to dig into a lot of those studies and see, what, if this affects this culinary herb this way, maybe I can try that with a medicinal herb and same benefits. And then now that there's starting to be some studies on cannabis, like the study I was mentioning showed that like drought stress in week 7 raised potency across maybe a couple cultivars. So I have noticed, at least what I appear is a direct correlation between some induced drought stress in late flower and higher potency. And I think it kind of makes sense because you're withholding water, so you have less water in the flower, and the cannabinoids or chemical constituents will kind of naturally be a little more concentrated because the biomass is just lower and they have the same amount of chemical constituents there. But also, I think, there's definitely some types of stress like that you can incorporate to potentially raise potency. I think I may have been overwatering a bit in late flower earlier, and as I've kind of started to draw back on water in the last 2 weeks, I have seen increases in potency. Is it directly related to that? Pretty hard to say, because I've done other things too, and I've reduced temperatures more in late flower, and I'm sure there's a bunch of other things that I've changed in how I manage the flowers as I get into late flower.
If you were going to grow cannabis in a greenhouse, would you be trying to grow the same exact strains and cultivars that you're growing indoors right now? Or would you be trying to find other cultivars that would work well in a greenhouse type of environment?
Yeah, that's another great question. I guess I don't, with our current genetic library, I don't know because I've never tried to grow them outside. I think there's certain varieties that I would start with, just off best guess, but more so if, especially if we're trying to grow 12 months a year, I would pick plants with different growth habits for different times of the year.
What does that mean?
Maybe in the warmer months, especially if we're battling humidity, I would pick plants that tend to have more distance in their internodes that, allow more airflow, air penetration, light penetration, would reduce the risk of mold. And then maybe I save the other more compact plants with tighter internode spacing for the winter.
So that again sounds like your lettuce varietals in some ways.
Yeah. Almost like in the opposite way, like I said, but
same strategy, same forethought going into plant structure being related to the conditions you can create.
Are there particular plants? I mean, I know that you described some of the features that you're looking for in terms of air exchange and water and food and harvest index, but are there any plants you've grown that maybe weren't really good at doing those things, but thrived in microgravity or space?
Well, a Arabidopsis seems to do good, but you can't eat it.
Boring.
We've grown an awful lot of Arabidopsis up there, but things, I'm not aware of any.
Okay.
That's a really interesting question. That's gonna, it's gonna take some time. There are things that have low harvest index that have done well, like wheat or soybeans have been grown. There are things that have grown and produce flowers like the zinnias that were grown in the veggie that's been up there now. But they had a struggle getting that plant in. I wouldn't say they thrived, but they survived and they demonstrated what was possible. And if we can demonstrate that possibility on these low emissions and these, shall we say, lower fidelity growth chambers, in much ways it's humans breaking that 4-minute mile. Once somebody's done it, then it's easy to do it. When you
right,
it's like we can do this now. So now dozens of plants have been grown in that environment with low humidity, high fluctuating CO2. Are they optimal? No. Are they where you'd want them to be? Probably not. But do we have a baseline from where they are at to where we know they can be? Yes.
What is one piece of advice you'd give to a new grower?
Oh, that's a good question. I would say get a good understanding of all aspects of the technology that's going to go into your environment. Obviously, the growers, their main focus is going to be how we can get those plants to be as productive as possible or grow as healthy as possible. But they have to have a good understanding of this HVAC side, and they have a good understanding of the lighting side. It's part of things that happen certainly there. I would say just look at it tip to tail, the HVAC, the lighting, the irrigation systems, just understand the technology tip to tail.
Nice. Now, I mean, you guys were going back to the heating system. Thad, you said, one word you can answer that question, which is humidity. I mean, raising the temperature of the greenhouse, right, with your heating system, automatically reduces at least the relative humidity, if not the total moisture content of the greenhouse. Is that a strategy that you see employed very often, or a lot, or little?
It's a great question, and that's kind of touching on the comment of VPD too. Yeah, the growers always have ideal set points that they wish to grow to, and they don't always understand the economical impacts of those decisions. And one way to mitigate that decision is to keep your VPD intact, but change the coupled temperature and humidity set points to meet that VPD, but maybe you raise it to make the system a little more affordable. And, again, Jim said for tool makers, I agree. There are some kind of upper boundaries for each type of crop that the growers feel are limits that they don't like to exceed. But what we typically see is on the front end, growers typically want aggressive or the best ideal set points. And then what we usually see in practice afterwards is usually more economically balanced, where they may be willing to forego on temperature and humidity without sacrificing VPD. So
I'd add to that, we sell mechanical systems for air conditioning and cooling and we really don't want people to use them, if that makes any sense. Like we buy all this stuff, but only use it when you really, really have to.
Exactly.
And that kind of touches on the people that operate greenhouses if there's one downside about having a greenhouse versus an indoor facility, is that the mindset of the cultivator really needs to be steeped in operating a greenhouse, because dehumidification in a greenhouse can be done the traditional way, where you heat the space and crack the vents. And only then, when you get to a point where there's no return on it, should you shut down and use the mechanical system that costs a lot to operate. So, that there's always walking a fine line there, and the control systems can help, but having a qualified greenhouse oriented cultivator can never be undervalued. And we see it over and over again when people come from the indoor space where they have so much control and they try to operate a greenhouse. They have to cut their teeth for a while before they finally they're partnered up with a control system that's partnered up with all these apparatus that can vent or move air, et cetera, using those appropriately really can spell success or not.
It's like they're two different types of cars. They need two different types of drivers. And you have to learn each system if you flip over.
I just want to start really basic.
Yeah.
Why do cannabis projects or developers or growers or whatever, why do they need you? Why do they need an architect in the first place?
Good question, right? One reason is the building code. So these are factories. These are moderate hazard factories by definition. A grow facility is a factory moderate hazard. That's the building classification from the ICC, International Code Conference. That's the state level, right? And municipal level. There's a local building inspector, and they're concerned with life safety, not plant safety. And so many architects practice in cannabis without knowing a thing about the plant, right? I will make sure that you have the right exit doors. I'll make sure they're the right width. I'll make sure that the place won't burn. We'll get an engineer. We'll do sprinklers. Everything else, that's on you. So there's lots of opportunity to find very competent, good architects in that space. However, there's so many more aspects that architecture affects in plant health and plant growth. So happy plants is a good business, right? And airflow and all of those pieces have to do with air sealing in tight environments. So that's the room design. So what is a properly built grow room? Many architects just will do the shell for the customer and not worry about the room inside. So that room and its tightness is fundamental to air control, air movement, proper VPD, RH, maintaining all of your interior set points are really hard to do if you're growing in a plastic tent, right? So you don't grow in plastic tents. You grow or in a greenhouse. You want to make sure that the environmental controls can be maintained. Big differences between greenhouse and warehouse grows. So architects affect not only the superstructure, the piece that the local and state building authorities have jurisdiction over. If you find an architect who knows plant health and who understands the interaction between building systems and process systems and the flow of operations, then you can improve the business by shortening the number of steps that a crew have to go through. Well, that's planning and organization, and that's an architect's world. Selection of materials, so specifiers. Architects are specifiers for building materials. So if you know that you're using certain chemicals and you don't want them to peel your floor finishes up, then we want to specify the right floor finishes the first time. Or let's talk about C1D1 if you're extracting, right? What areas, in fact, are C1D1? Is it a HAL booth? Well, they went out of business, so maybe it's a Podtronics booth, right? Are there Lab Conco booths? How do you coordinate the power needed for that, right? So architects typically in industry coordinate the work of the mechanical, electrical, plumbing trades. So we bundle that. We provide coordination. We're not engineers. We're not purporting to be, but we help to facilitate the communication of the process systems, horticulture or manufacturing, and not necessarily translate that. I mean, we have engineers now who, like yourself, are completely immersed in this. We don't tend to work with novice engineers either, right? Or new engineers to this industry. So we often are a quarterback in coordinating room design and environment and overall facility and flow of that facility. We often quarterback with also some, rather mundane things like making sure that the security vendor is layered in and that the doors have the right security hardware on them. And then, for example, we work with equipment suppliers who will buy and warehouse and deliver just-in-time delivery. We're coordinators of all those various subtrades. And that's in industry, in hospital design, and secondary schools and university design buildings, that's the role of the architect, is that sort of quarterback amongst all host of specialty tradespeople, specialty design people. So that's where we thrive, because that was our experience prior to coming to cannabis and that saves customers time and money ultimately.
Is it possible to continue being an artisan or a craft in whether it's brewing beer or whether it's craft cultivation of cannabis? Can you still be an artisan or a craft grower at a large scale, or are you really moving away from that if you have to grow at large volume?
That's a really interesting question, because that's the dynamic that we all feel the push and pull from being on the craft side of things. So there's always a push and pull there, but yes, I think you can. And I think as far as craft cannabis goes, as well as craft beer, there is always going to be a place for it, because there is a lot of differences between the production models, the ingredients, the final product, the quality control. All of those things become very hard to maintain when you really ramp up scale.
If you were going up in space, what is the one plant you would take with you?
Ooh, now that one is a really, really hard one. I'm going to have to put a pin in that one.
Okay.
I'm going to have to put a pin in that one, because that one plant, I just had one plant, that would mean that I am not having to rely upon it for food.
Correct.
And it's going to have to be some perennial that's going to be continuously growing. It's going to have to be very, very adaptable. And it's going to have some connection back to Mother Earth. So what I am thinking now, I would probably take a little philodendron, because a little philodendron, they come down, and I used to have those when I was a child. and you can cut them off and they will prosper. They'll make roots very easily and they get vines, but they're really neat that if they start growing up the tree, their leaves get larger and larger and larger. So they're a gigantica. You can get them the size of plates or larger. But if they lay up on the ground, they're very, very small. And that's what you're sold as the ornamental. So, I might have, if that was the only one I had, I couldn't eat it, but it would clean out my atmosphere. It would take very low light, be easy to propagate. And I could, fill up my little space cubicle with vegetation that had these scents and smells and color and diversity of a variegated philodendron leaf.
And it reminds you of home. I love that.
Yeah.
What do plants crave from technology?
Yeah, that's a great question too, Nadia. The plants, they need the great environment to survive and thrive, right? So every aspect of it is important. But what plants want from HVAC technology in particular is something to be able to control and respond to changes. But in the end, plants don't care too much about your iPhone. They don't care too much about your computer. It's up to us to leverage the technology to give them what they want. And that's important, right? But I think it's an important distinction as well, where let's utilize the technology. Let's get the least amount of energy possible given our budget. But let's remember the plants care about the environment and not exactly how we're going to get there. So let's be creative about technology, and let's leverage it for energy efficiency and so on, and give the plants what they want, and that's just a space to grow.
Today's featured guests were Melanie Yelton of Grow Big Consulting, Bruce Bugbee, Director of the Crop Physiology Laboratory at Utah State University, Christine De Jesus, Director of Cultivation and GM at Galenas, Nick Denney, Senior Director of Cultivation at Holistic Industries, Gary Stutte, President and CEO of SyNRGE, Craig Burg, President of Desert Aire, Jim Rearden and Thad Humphrey, CEO and the Principal Engineer from Biotherm Solutions, and Brian Anderson, Partner at Anderson Porter Design. You can find all of these guests' full interviews in our podcast archive, wherever you listen to The Doctor Is In. Stay tuned for our next episode, which will be our 100th. We'll be celebrating at Indoor AgCon and hope to see you there. Find our table to record a segment with us and give us your conference takeaways on Wednesday, March 12th. Thank you for growing with us.